Okay, so we're going to look at some parent functions practice here. So in this first section, we're going to kind of check two things. One, we're going to match the picture to the parent function, and then we're going to check and see if it is 1 to 1. All right, so there's probably two ways you could attack this. All right, you could probably go through each graph and match the parent function to it, or if you want to look at your kind of parent function kind of word bank at the top there, you could start with those and then go to each one. So I'm kind of mixed up. The last practice, I started in the word bank and went to each one. Let's just go in order this time. So A. So looking at A here, this is a line, right? What you worked with most in Algebra 1. So when you look at this line here, okay, that equation is going to be f of x equals x, all right? Your exponent's 1. Okay, that's what made a linear function. Now, for the second question here, 1 to 1, all right? Reminder, if you have a graph and you are checking 1 to 1, all right, you're doing the horizontal line test. So I'm probably just going to make this horizontal line for all my problems, okay? And then I am going to just run it through each of my graphs. So for this first one here, remember, I am checking to see, does my horizontal line, does it only hit my graph once at all the spots? And in this case, it is yes. So is y or f of x equals x a 1 to 1 function? The answer is yes. It passes that horizontal line test, horizontal line. Okay, great. So as we move on, I think there's one extra 1 to 1 in here. So I'm just going to, let's get rid of this one. Okay, just kind of a printing mistake, editing mistake. No worries. So we'll get rid of that one. So let's do B over here. So first thing for B, you kind of have this wiggle shape here. Remember, if you're ever stuck on these, you can also kind of use some of the points to help you out. Now, we don't have giant pictures of these graphs, so you don't have too many points to work with, all right? But with this wiggle picture here, you have x cubed. Okay, I'm actually going to switch blue. Let's go back to red. X cubed. Now, when I go through and I do this horizontal line test to check and see if it's 1 to 1, come on, all right, I go through here. Now, even though it looks pretty close right here, I might be like, well, that's kind of horizontal, okay? The function of x cubed, the parent function here, is not going to hit more than once. It keeps approaching 0 at a very slow rate, okay, but it never actually hits more than once. So, all right, is this a 1 to 1 function? This answer is yes. Going down to C, this is that shape that kind of looks like a ramp a little bit, all right, kind of a weird one. It also has an asymptote on the x-axis. This is our exponential function. And as I test the 1 to 1 with this one, I go through and see, and then same thing kind of what I just talked about with x cubed, okay? All right, with that asymptote there, it might look like, oh, this fails the horizontal line test, but that just keeps approaching 0. All right, there's not a huge difference between a lot of those values, but there is a difference, so it's not actually hitting this horizontal line test. So this is also still a 1 to 1 function. All right, going down to the bottom group. All right, so think about which ones that we used so far. We've used x, we've used x cubed, we've used the exponential function 2 to the x. All right, so 4 parent functions left. We actually took log out, so I'm gonna get rid of log here. Okay, we took log out for you guys. So we got 4 left, all right? This next one down here, the dead giveaway is that you have no negatives. You have no negatives, so that is going to be your square root of x. I can't square root a negative. Can't square root a negative. So as I get rid of this circle, okay, so I'll make a new horizontal line. So as I do this new horizontal line, look, this is going to pass my horizontal line test. So we have yet again another 1 to 1 function. Okay, now our last couple. This one has your V shape here. So I think the easiest way, I can cross off square root of x. All right, I think the easiest way to remember this is remember absolute value. Okay, it's a capital V. It stands for value, absolute value. All right. That's the easiest way to remember this. So we have our absolute value parent function. Now this time when I run my horizontal line test, let's pick this up, bring them over here. Oh, come on. There we go. All right. When I run the horizontal line test, look, it fails. It hits more than once. So since this fails my horizontal line test, this one is a no. This one is a no. Now our last two look pretty similar. So if I cross off absolute value of x, I'm left with x squared and x to the fourth. Now they both are this parabola shape, so they're very, very similar, but let's think about points for a second. I have this 2 value here. If I plug 2 into 2 squared, x squared, 2 squared is going to give me 4. That's this point right here. Notice how that is not on this graph. But if I go over here, 2, 4 is on this graph. So that's why this one is going to be x squared, and this one's going to be x to the fourth, which is a little bit more narrow, a little more stretched out. All right? Now, they're both pretty much the similar shape. So when I go through and I try to run this horizontal line test, look, it hits more than once, and it's the same thing over here because it's the similar shape. So guess what? Both of these are going to be a no. Okay, so moving on to our next section. Decide whether each of the functions are even, odd, or neither, and give some sort of explanation as to why you made your choice. All right, and then as we go to describe it, we're going to use 2 a lot, a written description, the graph summary, or 3, okay? 2 or 3 are the main ones we looked at. We haven't really looked at the arithmetic work in our specific unit. All right, so we're going to pretty much use 2 or 3, and I'll kind of show you that here in a second. All right, so for the first 3, you are given the equation. Okay, you are given the equation. Now, when we're looking at the equation, you need to check and see to determine if it's an even or odd function. Even functions, all exponents with your x's, all your exponents are going to be even. Every single one of them has to be even, all right? For odd functions, every single exponent has to be odd, all right? And it has to be all or nothing for those. It's neither if it's any combo of those, okay? So as I go through and do these problems, this first one here, look, I have 4, and then I have just an x here, which remember, that exponent is 1. So take a look. With 4 and 1, 4 is an even number, 1 is an odd number. I have a mixture. So this reason is going to be neither. And my reason, I can just say I have even and odd exponents. Done with that. So if I go through and do the rest of these problems, take a look. This one has 4 and 2. All right, now constants are a little weird. Remember, you typically have an x of 0 there, which is a little interesting, but remember, anything to the 0 power is 1. Okay, and then obviously that becomes kind of useless because 1 times 1 is just 1, so we don't really need that. All right, but looking at the 4, looking at the 2, I have a bunch of even exponents, so guess what? This one's going to be even. Got all my even exponents. And then my last one here, I got 2 exponents. I have the 3. And just like I talked about with the first problem, there's technically a 1 there when it's just x. Well, hey, 3 and 1 are both odd numbers. So guess what? This is an odd function. Odd exponents. Okay, and then if I had to add one more word to this, I'd probably put all odd exponents, all even exponents. That first one we did had even exponents, had odd exponents, but they weren't all. It was a mixture of both, okay? So just kind of wanted to clarify that a little bit. Be careful with that. So when we go ahead and do the graphs, all right? When we do the graphs here, there's 2 things I'm looking for. I am either looking for even functions are going to reflect over the y-axis, and sorry, I don't know why my writing's a little laggy there. Goodness. All right, and then odd, we are going to look for reflect over the origin. Shoot, I hope that catches up a little bit. Doesn't look too bad. All right, 0, 0. I know my handwriting's not the best. So as we go through and do this, okay, these are going to still be odd, even, or neither. And neither pretty much just means it doesn't reflect over either of those. So looking at this first one, I always like to start with even because I think it's a little easier to see. Now, you're probably not going to mark up graphs like this. You're probably just going to look. But if I wanted to see if something reflected over the y-axis, all right, pick a point. I'm going to take this point right here, pretty random. If I reflect it over the y-axis, I should have a point right there. I don't. So right away, I can rule out even. Now, odd, I'm going to reflect this over the origin. Okay, now remember, reflecting over the origin, it's not a specific line or anything. You're going to take a point and you basically go to the diagonal quadrant over it. So like reflecting over the origin here would go to here. If I want to reflect a point down here to the origin, that would be here. I would reflect that up here. And if you take a look, no matter what point I pick, it gives me another point on that graph over there when I'm reflecting over the origin. So guess what? This is going to be an odd function. And I can say it's symmetric, it reflects, over the origin. And that's how you roll through and do those. So as I keep going through and doing that, take a look here. Now this graph's a little weird. It doesn't have like the X markings, but look, there's your origin right there. So the first I like to check Y. Take a look. Yeah, it doesn't reflect over Y. So then I'm going to take a look at the origin, okay? I'm going to take a look at the origin. It doesn't reflect over the origin. All right, I'd probably be around here. No, so this is going to be your neither. This is going to be your neither. And then I'm just going to say not symmetric over origin nor y-axis. And I hope that doesn't look too bad. Like I said, sorry, it's a little laggy right now. All right, and then my last one here is going to be, take a look, let's check. All right, let's check with reflect over y-axis. Here to here. Oh, that looks pretty good. And if I go through and pick any 2 points, yeah, look, it is going to reflect over the y-axis. So our last one here is even. So this is going to be even. My reason is going to be reflect over y-axis. Okay, so I'm going to stop this video here. It's being a little bit laggy, so I'm going to try to restart this iPad. All right, but this is page 7 of your parent functions practice. All right, I'll just do page 8 in a new video.